Software, an intangible web of instructions governing our digital world, has become ubiquitous. From the mundane to the mission-critical, it permeates every facet of modern life. High-quality software is reliable, efficient, secure, and user-friendly. It consistently meets user expectations, fostering trust and satisfaction. Conversely, poor quality software can have detrimental consequences. Bugs and errors can lead to system crashes, data loss, and financial setbacks. Security vulnerabilities can expose sensitive information to malicious actors. A poorly designed user interface can frustrate users and hinder productivity. In extreme cases, software failures can even have life-threatening implications, particularly in industries like healthcare and aviation. High-quality software enhances customer satisfaction, strengthens brand reputation, and provides a competitive edge. It reduces development costs by minimizing rework and bug fixes. Recognizing the crucial role of software quality, numerous models and frameworks have emerged to guide organizations in their quest for excellence. The ISO IEC 25010 standard, an internationally recognized framework, provides a comprehensive model for software product quality. It defines 8 characteristics that contribute to overall quality: functionality, reliability, usability, efficiency, maintainability, portability, security, and compatibility. Each characteristic encompasses sub-characteristics, providing a granular perspective on quality attributes. Functionality refers to the software's ability to fulfill its intended purpose. Reliability ensures the software performs consistently and accurately over time, minimizing failures and errors. Usability focuses on the user experience, emphasizing ease of use, learnability, and user satisfaction. Efficiency pertains to the software's resource utilization, including processing speed, memory usage, and response times. Maintainability addresses the ease with which the software can be modified, corrected, and enhanced. Portability considers the software's ability to operate effectively in different environments, such as various hardware platforms or operating systems. Security safeguards the software and its data from unauthorized access, use, disclosure, disruption, modification, or destruction. Compatibility ensures the software interacts seamlessly with other systems, applications, or devices. By defining and measuring these characteristics, organizations can assess the quality of their software products objectively. The Capability Maturity Model Integration, CMMI, is a process improvement framework that helps organizations enhance their software development and maintenance capabilities. Developed by the Software Engineering Institute, SEI, at Carnegie Mellon University, CMMI provides a roadmap for organizations to assess their current process maturity and identify areas for improvement. It is based on the premise that higher process maturity leads to higher quality software products. CMMI defines 5 maturity levels, each representing a progressively more mature and capable process: initial, managed, defined, quantitatively managed, and optimizing. At the initial level, processes are typically ad hoc and unpredictable. As organizations progress through the maturity levels, they establish more defined, documented, and measured processes. The managed level emphasizes basic project management practices, such as planning, tracking, and controlling software development activities. The defined level focuses on establishing standardized processes that are well documented and consistently followed. The quantitatively managed level introduces quantitative techniques to monitor and control process performance. Finally, the optimizing level emphasizes continuous process improvement and innovation. By implementing these best practices, organizations can improve their software development processes, reduce defects, and enhance product quality. The framework is adaptable to different organizational sizes, cultures, and development methodologies, allowing organizations to tailor its implementation to their specific needs. Six Sigma, a data-driven methodology, originated in manufacturing but has found widespread application in software development. Its primary goal is to reduce defects and variability in processes, ultimately improving the quality of products and services. Six Sigma employs a structured approach known as DMAIC, define, measure, analyze, improve, control, to identify and eliminate the root causes of defects. The define phase focuses on clearly defining the problem or opportunity for improvement, setting goals, and establishing project scope. The measure phase involves collecting data to quantify the current performance of the process under investigation. The analyze phase aims to identify the root causes of defects or variations in the process. Statistical tools and techniques are often used to analyze data and pinpoint areas for improvement. In the improve phase, solutions are developed and implemented to address the identified root causes. The control phase establishes mechanisms to monitor and sustain the improvements over time, preventing the recurrence of defects. Six Sigma emphasizes data-driven decision-making, rigorous statistical analysis, and a relentless focus on customer satisfaction. By reducing defects in these processes, organizations can deliver higher quality software, reduce development costs, and improve customer satisfaction. Lean software development, inspired by lean manufacturing principles, focuses on optimizing efficiency and delivering value to customers. It emphasizes eliminating waste, empowering teams, and continuously improving the software development process. Lean principles encourage a customer-centric approach, where development efforts are aligned with delivering value to end users. One of the core principles of lean software development is eliminating waste, which encompasses any activity that does not add value to the customer. This includes unnecessary documentation, rework due to defects, delays in handoffs, and building features that are not essential to the core product. By identifying and eliminating waste, organizations can streamline their development processes and deliver software faster. Lean software development also emphasizes empowering teams to make decisions and take ownership of their work. This fosters a sense of responsibility and accountability, leading to higher quality output. Cross-functional teams, where members from different disciplines collaborate closely, are encouraged to promote communication and reduce silos. Continuous improvement is another cornerstone of lean software development. By embracing lean software development principles, organizations can reduce development time, improve quality, and increase customer satisfaction. While each software quality model offers a unique perspective and approach, they are not mutually exclusive. In fact, these models can complement and reinforce each other, creating a synergistic effect that elevates software quality to new heights. Organizations can leverage the strengths of each model to create a comprehensive and robust quality management system. For instance, ISO/IEC 25010 provides a comprehensive framework for defining and measuring software quality characteristics. CMMI focuses on improving process maturity, which indirectly enhances software quality by establishing standardized and repeatable processes. Six Sigma provides tools and techniques to reduce defects and variability in processes, leading to more reliable and predictable software. Lean software development emphasizes eliminating waste and delivering value to customers, which ultimately contributes to higher customer satisfaction and improved software quality. By integrating these models, organizations can create a holistic approach to software quality management. This integrated approach ensures that all aspects of software quality are addressed, from process improvement to product characteristics, resulting in higher quality software that meets customer expectations. The effectiveness of software quality models is evident in their widespread adoption and the success stories of organizations that have implemented them. Across industries, these models have helped organizations improve their software development processes, enhance product quality, and achieve business objectives. In the aerospace industry, where software failures can have catastrophic consequences, rigorous quality standards are paramount. Companies like Boeing and Airbus rely heavily on models like CMMI and DO-178C, software considerations in airborne systems and equipment certification, to ensure the safety and reliability of their software systems. In the financial services sector, where software handles sensitive financial transactions, security and reliability are critical. Banks and other financial institutions often adopt models like ISO/IEC 27001, Information Security Management System, and PCI DSS, Payment Card Industry Data Security Standard, to establish robust security controls and protect customer data. The healthcare industry relies increasingly on software for patient care, from electronic health records to medical devices. Models like IEC 62304, Medical Device Software, Software Lifecycle Processes, and HIPAA, Health Insurance Portability and Accountability Act, provide guidelines for developing and maintaining safe and secure medical software. These models ensure that software meets regulatory requirements, protects patient privacy, and supports the delivery of high-quality healthcare. The abundance of software quality models can be overwhelming for organizations seeking to improve their software development practices. There is no one-size-fits-all solution, and the best model for a particular organization depends on its specific needs, goals, and context. Factors to consider include the organization's size, industry, maturity level, and the complexity of the software being developed. For organizations new to formal software quality initiatives, starting with a lightweight model like lean software development might be a good approach. Lean principles can help identify and eliminate waste, empower teams, and foster a culture of continuous improvement. As organizations mature, they can explore more comprehensive models like ISO IEC 25010 or CMMI. Organizations developing safety-critical software, such as those in the aerospace or medical device industries, may need to comply with industry-specific standards like DO 178C or IEC 62304. These standards provide specific guidelines and requirements for software development, verification, and validation to ensure the safety and reliability of critical systems. It's important to note that organizations are not limited to adopting a single model. In many cases, a combination of models can be used to address different aspects of software quality. In the ever-evolving landscape of software development, quality reigns supreme. Software quality models provide invaluable frameworks and guidelines for organizations striving to deliver exceptional software products. From the comprehensive nature of ISO IEC 25010 to the process-centric approach of CMMI, the defect-reducing focus of Six Sigma, and the efficiency-driven principles of lean software development, these models offer a toolbox of techniques to elevate software quality. By embracing these models, organizations can transform their software development processes, improve product quality, and achieve business objectives. Implementing these models requires a commitment to continuous improvement, a culture of quality, and a focus on delivering value to customers. Organizations that make this commitment reap the rewards of higher customer satisfaction, reduced development costs, and a competitive edge in the marketplace. As software continues to permeate every aspect of our lives, the importance of software quality will only continue to grow. By embracing software quality models, organizations can navigate the complexities of software development, deliver exceptional products, and shape the future of technology in a positive and impactful way. The pursuit of software quality is not a destination but a journey, and these models provide the roadmap to guide organizations on their path to excellence.